Welcome to Psychology 101. Today we are going to examine the mechanics of human memory. When I was younger, I thought memories were like pictures that were filed in your head until you wanted to pull them out and look at them. In reality, memory is much more complex and fluid than that. Rather than files that are stored in our heads, memories can best be understood as electrical patterns played over and over again in our brains. Scientists who use the Multisystems model view memory as a set of systems that work together so we can remember different types of things. First, they divide the systems into the declarative and non-declarative memory, also called explicit and implicit memory. The declarative or explicit memory includes the systems that we consciously control. These are operated mostly by the hippocampus and frontal lobes. This means that head trauma can damage your declarative memory. Old age also causes declarative memory to decline. Let's take a look at a few systems under declarative memory: the working, episodic, and semantic memory. The working memory is the shortest kind of memory, lasting about 2 to 18 seconds. Let's say you're trying to get a friend's new number. They read it off to you, and then you type it into your phone. This is where your working memory comes into play, storing the number in your head for the few moments you need to type it in. Episodic memory is a long-term memory system that stores information about events that have happened to you. This is how you remember what you ate for dinner last night, that joke your friend made in the hallway last week, and that time you threw up on a stranger in an airplane. Semantic memory is also a long-term memory system. It stores general knowledge, like Des Moines being the capital of Iowa and Neil Armstrong being the first man to land on the moon. Now let's go back to that second kind of memory, the non-declarative or implicit memory. This is a part of our brain that we don't consciously control. It is run by the cortical areas, cerebellum, and basal ganglia. Let's check out three kinds: priming, procedural memory, and classical conditioning. Priming is an uncontrolled process where we are able to make associations and retrieve memories faster in response to certain cues. For example, you can read the word pickle more quickly if you've read it recently. Ever seen that trick where someone tells you to say silk 10 times fast, then asks you quickly what cows drink? You probably said milk, even though the answer is water, partially because your brain was thinking about silk, which is close to milk. Procedural memory is more commonly referred to as muscle memory. This is how you always remember to ride a bike once you've gotten good at it. It's also how you remember to type, play the violin, and really perform any physical action you learn. Classical conditioning has to do with associations formed automatically in your brain. The famous example of Pavlov's dogs is the most well-known case. Ivan Pavlov was a Russian physiologist who performed an experiment on dogs. Each time he fed them, he would ring a bell. Soon they associated the sound of the bell with food. The association was so strong, they would start to drool whenever they heard the bell, even if there was no food in sight. So, to recap, memories are electrical patterns played over and over again in your brain. The Multisystems model divides them into declarative or explicit memory and non-declarative or implicit memory. You control your declarative memory, which includes your working, episodic, and semantic memory, and is controlled in your hippocampus and frontal lobes. On the other hand, you don't control your non-declarative or implicit memory that includes priming, procedural memory, and classical conditioning. In conclusion, memory is a large and important part of our psychology. It shapes our identity, and without it, we wouldn't be able to do something as necessary as driving a car. So the next time you remember not to touch a hot stove, or laugh thinking about that cat meme you saw on the internet, remember to thank your memory.